I thought I'd say a few words here about why it is that we know that the energy density of a gravitational field is negative. So this is kind of a thought experiment which is intended to illustrate that fact, all in the context of Newtonian gravity. You just have to take my word for it that similar things happen in general relativity. So we want to imagine a thought experiment of having a spherical shell of matter, empty inside, just a shell on the surface. And I need to know what the gravitational field of that looks like. And it was calculated by Newton. It's in his Principia. So I'll just tell you the result. Many of you, I'm sure, know this. And if you don't, you'll just have to believe me. The result is that outside the shell, the gravitational field is exactly what it would be if the whole mass of the shell were just a point mass at the origin, just a 1 over r squared force. So these force lines shown outside are supposed to represent that. Inside the spherical shell, the gravitational field is exactly 0. It cancels out in the different directions. So the sum, when you add up the force due to the attraction to each bit of mass around the shell, adds up to exactly 0. And Newton figured that out, too. So now what I want to do in my thought experiment is to imagine that this shell is made out of something flexible, putty of some sort, clay, so that I can allow it to collapse under its own self-gravitational force. There'll be a force on the shell pulling inward. Every particle in the shell will be pulled by the other particles of the shell, and the net force will be inward on any particle of the shell. So I want to take advantage of this inward force to generate power. So in my thought experiment, I'm going to imagine attaching a whole large set of generators by strings. The generators are in fixed position. The strings go from the generators to the surface, and I'm going to allow the surface to collapse under the force of gravity, pulling on those strings, turning the generators, generating power. So in this second stage here, power is generated by the inward motion of the shell. Then we stop and ask ourselves what's happened all in all. How do we add things up? And in this final picture, what's being shown is the position of the outer shell, which is shown as this dashed line, the new position of the shell when we finish the process, shown as the solid black line, and the gravitational field. And this shaded region is the region which has gravitational field at the end of the process, but had no gravitational field at all in the first picture at the beginning. So the net effect of the entire operation is to generate power by the generators that we pulled on the strings and activated, and to create a new region of gravitational field where previously there was no gravitational field. So the only way that could be consistent with energy conservation is if somehow the energy for the power that was generated can be accounted for by this new region of gravitational field. And that means that the new region of gravitational field has to correspond to a negative energy. So the total energy is the same as what we started with. So this is a simple demonstration in the context of Newtonian gravity that the energy of a gravitational field has to be negative.